All right, I've been given these questions from a couple of lessons ago, quite a lot of thought, and I think I have a method which is slightly easier than the one I went through at the end of last lesson. Oh, 2 lessons ago. Right, so remember this question we did in class, just at the end. I did it in quite a long way. Now this one we're going to approach by converting to degrees first. You're going to have to get used to using radians, but we're just going to do this one by converting to degrees because some of you may prefer it. So your starting point is you have to know 1 pi radian, so 3.14 or so radian is equal to 180 degrees. I want 7 over 6 pi. So I'm going to times both of sides by 7 over 6. And then we should see that 7 pi over 6 radians is equivalent to 210 degrees because 180 divided by 6 is 30, and 30 times 7 is, of course, 210. So the equivalent in degrees would be cosine of minus 210 degrees. Then I would draw your angle on a cast diagram. You could easily get the equivalent, of course, by adding 360 degrees, but we're going to do all these with the cast diagram. So it's negative, so it's going this way, and it's going 210 degrees, and then you see which quadrant it ends up in. So because I've gone past 180, which would be here if I went in that direction, or indeed the other direction, then I've just gone past it, and I've gone 30 past it. Now this is really important. How far I've gone past the x-axis. I've gone 30 degrees past. All the angles make this angle with the x-axis, and it can help us find the other angles. So this is our key angle, and that's the one we want, minus 210. Right, so let's remind ourselves of what cast is. So there we go. Remember, you start in bottom right and just write out the words cast. Now, we're looking at cosine. So, and it's ended up in this quadrant. So the cosine of minus 210 degrees, the answer is going to be negative because it would be negative in both of these quadrants. But it's positive equivalent, so same answer but positive, would be here and indeed below that. So you can actually easily convert to its positive equivalent. So its positive equivalent is an angle we know. It is 30 degrees. So if we work out cosine 30 using our special triangles, which I can refer to here, so cosine 30, try that again, which I can refer to here. So cosine 30, here's our special triangle for cosine of 30. So it would be adjacent over, so there's the adjacent, over hypotenuse. So we're looking at cosine 30 being root 3 over 2. So use your special triangle, Bosch. Well, that, remember, is positive. So that it's going to be, cos 30 is positive because it's in this quadrant. But what we want is its negative equivalent because we ended up in a negative quadrant where cosine is negative because we got that s there. So actually, the cosine of minus 210 is minus root 3 over 2. Now we're going to do a few more of these just to get the hang of it. But I think that's the best way to do it. Now remember, we could do this. We did it using symmetry last time. So, and you can do this. Some of you will prefer, I think, knowing the graphs and using symmetry and kind of whatnot is also very useful. You need to know it. So that's a cosine graph, that is. Now, I know that is 180, right in the middle there. Now, if I was trying to find minus 210, what I'd probably do is get its equivalent. I'd add on 360. So I know its equivalent angle is 150 degrees. So that will fit up with the graph I've drawn there. So 150 degrees would be about here. Ugh, it's not use yellow. Would be about here, 150 degrees. And it would give us that solution I've marked out. Now that would be equivalent, using symmetry, to this solution here on the positive axis, where it's 30 degrees on the x-axis. So we get exactly the same answer. In other words, on the y-axis, at the positive part, it would be root 3 over 2, where you've got cos 30, but you're looking for its negative equivalent, which is minus root 3 over 2. Right, let's do, I'm afraid I've got 3 more planned, but it should get quicker. So we're going to try and use the same method. But this time, let's try and get used to using radians, please. So I've already drawn them out a little bit, as you can see. So the first one is, we are picking these in order, I think. So in order then, first angle is cos 5 pi, or the angle is 5 pi over 4. So that would be here. Remember, you go anti-clockwise for positive angle. So 5 pi over 4 would be there, just past pi, just past 1 pi or 180 degrees. So that would make an angle of pi over 4 with the x-axis. Now, cos here is, we're looking at cosine, and crikey, again, it's going to be negative because it's ended up in that quadrant where we got a t. So you go to your special triangles. This time we're looking at pi over 4. I've already forgotten what it was. Cosine. Yeah. So cosine pi over 4, otherwise known as 45 degrees. So cosine of 45 degrees is 1 over root 2. Here it is. So that's the one we want. So all we have to remember, though, is the negative of that. So cosine 5 pi over 4, and genuinely just forgotten what I said. 1 over root 2. So it's minus 1 over root 2. So use your special triangles. We've identified it's the angle pi over 4. So then we can use our special triangles. But it's because it's in that quadrant and it's cosine, it's going to be the negative answer. Right, let's look at the next one. Next one's a nice one. Sine pi over 3. Sine pi over 3. So that's going to be in the first quadrant. We go to our special triangles. This one is there straight away. Pi over 3, of course, is 60 degrees. So sine pi over 3, sine 60 is root 3 over 2. Well, that's it. We're done because it's in the right quadrant. So sine pi over 3 is root 3 over 2. That is right, isn't it? Yes, it is. Done. So that's the first two. Remember, we're just putting these in order. So they've got a negative and a positive. So that should make it fairly easy so far. Now, the next one was a negative. So you're going the opposite direction. You're going minus 5 pi over 6. So it's not quite pi. You're not quite going 180 degrees, but you've gone the other direction. You've gone negative. So you'd end up here. And that would make an angle of pi over 6 with the x-axis. So let's look at what tan pi over 6 would be. Pi over 6, remember, is 30 degrees. So tan pi over 6, tan 30 degrees is 1 over root 3. So it's 1 over root 3, and goodness me, it's ended up in the tan quadrant. So that means it's going to be positive. It's going to be positive results. It's going to be 1 over root 3. It's not going to be minus 1 over root 3. So then, to put them in order from, let's say, smallest to biggest, I can't actually remember what the question is. So it'd be cos 5 pi over 4 is the only negative number, followed by tan minus 5 pi over 6, followed by sine pi over 3 would be the biggest number of those three. Right, next one's actually weirdly easier, because finding the exact value of this, we know we can just get these from our special triangle. So you go, we know pi over 3, we know pi over 6. So pi over 3 is, whoopsie daisy. So tan pi over 3 and tan pi over 6. So we're looking at this one. That's tan pi over 6. And this is tan pi over 3. So we're looking at 1 over root 3 and root 3. Right. Let's do this then. So tan pi over 3 is root 3 minus minus 1 over root 3. Oh, this is fun. Over 1 plus root 3 times 1 over root 3. Let's make sure I got those the right way around. So tan pi over 3, which is 60 degrees, is root 3. Let's just make sure I don't make a careless mistake. Yeah. So tan pi over 3 is root 3. Right. Now you've got to simplify this. So the first one's quite nice. So I would make a common denominator of root 3. So you're going to do root 3 times root 3 minus 1 on top. And then on the bottom, the root 3 and root 3 here is going to cancel out. So you're just left with 1 plus 1. Then root 3 times root 3 is 3. So you've got 3 minus 1 over root 3. And all of this divided by 2. So divided by 2 over 1. So let's simplify further. So we got 2 over root 3 times by 1 over 2. Goodness me. Look at this. I've been this excited before. Cancels down then, incredibly, to 1 over root 3. Right, last one. So here, I think you have to find the coordinates for P. So you have to work out what P is. So this goes back to your unit circle. So here is your unit circle again. Remember that the x-coordinate is your x-coordinate is cos theta and your y-coordinate is sine theta. So cos theta, sine theta. So we know what theta is. It's the angle there, 225 degrees. So our coordinates are going to be cos 225, sine 225. And then we're on our little merry-go-round again. So let's do it. Same angle. That's nice, isn't it? So we're looking at 225 this time. So it's positive angle. So we're going in the positive direction. There's 180. Bosh. So it's going to be going past 180, but not reaching 270. So it's going to make this angle here, which is 45 degrees past 180. So it makes an angle of 45 degrees with the x-axis. Let's write out cast again. Yay. C-A, yikes, S-T. So it makes an angle of 45 degrees with the x-axis. Let's look at the first one. So we're looking at cos 225. So in this quadrant, it is going to be negative for cos because it's t. It's going to be negative for sine as well. So we're going to look at cos 45 then, go back to and then make it negative. So we go all the way back to our special triangles. Here they are. So we're looking for cos 45, which is 1 over root 2. So 1 over root 2 then. But remember, because we ended up in that quadrant, it's negative. So it should be, it should be 1 over root 2 minus 1 over root 2, because it's negative there. And then we need sine 45, because it's made that nice little angle of 45 with the x-axis. So you go back to your special triangles here. So sine 45 is this one. Sine 45 is 1 over root 2. Goodness gracious me. Look at that. But remember, because sine would be negative in that quadrant as well, it would be minus 1 over root 2, not 1 over root 2. Okay.